Hi, in this module, we're going to talk about data standards, when to use them and why to use them, and what using standards can do for us. I will motivate this whole module by giving you an example from data sharing workflow. A typical data sharing workflow in clinical research involves collaborators who usually approach a local site where data is being collected or some regional or central data collection entity. And that starts when the collaborators approach the stewards of the data. That usually starts what I call a data transfer dance. And part of that interaction involves the collaborators requesting certain data elements from the local sites. They usually provide a standard operating procedure with the variables and the variable definitions as they would like them to be provided. The site usually responds with agreement for complete or partial participation, so they're either giving them a subset or the entire data set that they have. Then they typically discuss how the data needs to be transformed, who has to do the data cleaning and the transformation so that it's compliant with the analysis requirements. And then usually there is a bulk transfer of the data from the participating site to the analysis center or to the collaborators. And it's inevitable that during analysis, certain problems would arise in the data or certain records would be flagged for more careful examination. And then there's usually back and forth individual queries that need to happen. This involved workflow is if the local site and the collaborators if the collaborators request the data in a specific format and the local sites store the data in a different format, then this kind of dance has to be unique for every collaborator and every site. And so you can imagine how when collaborators approach multiple or try to collect data from multiple data providers, or multiple providers are trying to get together to write a uniform manuscript, for example, in the case of data sharing, this can become cumbersome. So the complexity there becomes this kind of interaction has to happen in our case, 7 different times. And so you can also imagine how this kind of complexity also is multiplied if that same group of data providers is approached by multiple collaborators requesting data in their own specific format. So you're going to have a sort of an explosion of different interfaces between people requesting data and people who are going to provide that data. And this can get pretty cumbersome and very time-consuming. Remember that the data is for these analyses. Data is usually specified using a standard operating procedure, and that the local sites also have their own standard operating procedures. So, can we look at the different standard operating procedures and kind of logically ask, is there a way where we can use one standard operating procedure? So this would be a schema like the one we have here, where you have the local databases, but if we can somehow change the structure of the data, and data could be stored in tables with variable names and a certain tabular structure with certain column names corresponding to different variables that you collect. If we can somehow transform those so they all look the same, so everybody has the same column names and they store the same types of assertions down the rows in these tables, if we can have everyone save their data in tables that look the same, then it would be easy. It would just be a simple process, and harmonizing data from all these sources would just be collecting all that data and merging the rows in those tables. And typically also when people talk about standards, they also often refer to certain data quality checks that are specific to that standard. So if I go and say I want to define a standard where the date of birth has the variable for date of birth has a certain name, and other dates that are pertinent have other names, then it's implicit that no other observation about me, so I couldn't have a medication or a lab result that happens either before the date of birth or after the date of death, if the patient record has a death date. So these are the kinds of standards both in terms of data quality as well as structure that people can agree upon, and then that would make in an ideal world, everyone would have a standard compliant copy of their local data, or they would store the data directly in a standard compliant manner that then can be shared with other people. So one of the advantages of having a copy of your data in a standard compliant format, and this is often when people collaborate with each other, often they, usually you see such a standard emerging, and it's essentially a consensus on how people want to store the data to avoid this duplication of work. And one advantage of having a copy of your data or your data set in that standard compliant manner is that it's instantly machine readable. So you can overlay on top of that any kind of, for example, statistical software analysis, statistical analysis that expects this standard format for the data. And the kinds of things that you can do, in addition to the quality checks that I mentioned, you can spend time and invest in fancy scripts that produce very complex visualizations. You can do, for example, if you are collecting epidemiology data from different registries around the country, then you can, and that everyone is using the data in a specific format, then it would be worth someone's while to write geomapping or some complex mapping software that we know that all you have to do is just go around and harvest all that data, and then you can produce those beautiful visualizations. You can write templates for reports. So if all the collaborators have their data in a certain format, then you can write a template and ask everyone to run the same template, and then you would essentially get reports that look identical or that can be easily merged together. You can also write analyses upfront or even ad hoc, where you think of some kind of pattern that you're looking for in the data. Let's say you're looking for certain patients a subset of patients that have a certain criteria or a certain temporal pattern in say a certain lab result. Then you can write any arbitrarily complex analysis you want and then instantly run that analysis across all your collaborators. Another thing you can do with data that it conforms to a widely accepted standard is then you can also invest in building a software that can take that data, not just statistical software, but other software that can do useful tasks like manipulation, transformation of the data to meet other standards if they exist, or to meet other kinds of analysis-ready formats. You can write software that allows people to automatically merge the data from the different resources or repositories where they live. You can grab that data and make it accessible via the web, and that's also all predicated on the fact that the data on the back end is in a standard compliant format, so you can easily merge it using these software. And one of the things you can do, and this is why registries typically are encouraged to, or when local sites usually submit data to registry, that's why they use standard, because you can also very quickly run aggregate data operations. So you can look at means and populations and trends, or you can drill down to record level data operations and target certain records for more examination. So this now is a more simplified schema of the data sharing workflow that I've shown originally. In this data sharing workflow, you see every site for their own purpose may have their own internal data representation. That could be either their legacy database or something that they believe is more suited for their daily operation. Then all the site has to do locally is to create a standard compliant copy, and that effort can be done once. And then they have the data that just essentially what the schematic is showing, that it's when you collect data, it's the equivalent of stacking cylinders that all look the same. So you don't have to worry about making them all fit together. So this is the workflow. Another alteration to the workflow is the parallel analysis. And this is what I mentioned earlier. When you write, you can create analyses or report templates or these complex visualizations. And this scenario is when the sites do not want to relinquish control of their own data. So an external source or a central source would write the analysis that needs to be run. It would be pushed out to the sites, and then all the participating sites would run the data, would run the queries, and then submit aggregate results. So this is another workflow that's made easier when standard compliance, when data is stored in a standard compliant manner. So to recap in this scenario that I've been talking you through, the benefits of adopting data exchange standards, you have to do the data transformation and the quality checks only once. The standard compliant copy of your local database is ready for instant transfer whenever is needed. So whenever you choose to participate, it's just a matter of releasing your data. There's no more massaging or transformational work that you have to do. There's identical quality checks that are performed across the participating sites. Everybody knows how the data should look like. So there is a minimum set of quality checks that everyone runs, and people can write communal code or communal tools and share them with each other to ensure this kind of quality control is uniform across all the participating sites. And an important side effect is when you try to transform the data into a standard, you do two things. You standardize the structure or the syntax of the data, but also this can help you bring you closer to standardizing the meaning. So the semantics of the certain types of states that you capture or of certain types of assertions you make with the data. So instead of having multiple silos or registries assigning the label lost to follow-up to a certain patient based on their own local criteria. So one clinic can say, this patient is lost to follow-up because that's what we consider someone lost to follow-up if they haven't come for a visit in 6 months. Another clinic can say, can assign lost to follow-up to patients who haven't been seen in 3 months, for example. But now when everybody's using the data in a similar standard, if that standard requires you to define that label, then the definition would most likely be uniform across the board. Or the better case scenario is when you capture just the types of visits in the case of the follow-up, and then you can calculate it in a uniform way across the whole group. Another example is, what does it mean if a patient has TB? One site in one region or in one clinic, if it's a primary care clinic, a patient has TB if there was a diagnosis that was made by an external clinic, for example, whereas in a specialized infectious disease clinic, the meaning of a patient having a TB disease state is very much an operational definition that could come out of, for example, a TB culture being positive. So standards when sharing data using standards, people are more likely, but not necessarily so, but they are more likely to use, to agree on the meaning of topics, and that generally leads to better data harmonization. So beyond data exchange, and the example I gave today to motivate the kind of a use case for standard, you can use standards beyond data exchange scenarios. In data capture, case report forms typically have common data elements, and it's if I and Paul has referred to this in other series, in other videos, but if I define the gender or sex variable to be either MF or 1 for male, 0 for female, we can have different case report forms, but if we all kind of agree on the same, we can use the same standard for case report forms or a same definition for these data elements that are for data capture, then data capture could be better harmonized. Storage and retrieval is usually, there are standards that allow you to represent and store your facts, and you can aggregate them and retrieve them in an easy manner, especially if the standards and the labels that you're assigning to the different diseases, for example, are hierarchical. Then there are standards that allow you to do that kind of meaningful aggregation and retrieval. The same goes for analysis. If you remember, in the workflow that I was showing, the collaborators typically approach other local sites with standard, with their SOPs, and usually the group doing the analysis, their table structures and the structure that they would like for the data is very much related to how they would like to an analysis-ready table. So there are standards around analyses, and I'll discuss those later. And regulatory compliance can be easier to require compliance or to verify that you are compliant if the compliance refers to a certain specific standard and you show that you follow that standard. Then it will be easy for someone to verify that your data or your procedures using the data that's in a standard format complies, like other sites that have the same format, complies to a regulatory mandate, for example. And then last but not least, standardizing your data or how you store your data or using a common standard may allow you to reuse and repurpose your data down the road. So if you use a standard that has a clear meaning to it, then down the road you can kind of pull it back up and you know exactly how you stored it, and you know you can easily merge it with other data that you may have from other data collection and just repurpose or reuse it for other studies.